Measures of location and spread for grouped data. Example 2. The data here is identical to example 1 in the previous video. So we've got some data rounded to the nearest kilogram. So we need to work out the number of items which were below 16 kilograms. Now the number of items is a discrete value, so it should be a whole number. Now on the data scale here, 16 kilograms falls into this class interval. So using the interpolation formula, the data value, data, is 16. So that goes there. The lower boundary here is 14.5. The frequency of the class is 14, that goes here, and the class width, 14.5 to 19.5, is a width of 5, that goes here. The only value that we do not have is the frequency into the class. This is what we have to work out. This will contribute towards the final solution. So substituting the values in, rearrange to work out the frequency into the class. So 4 of the 14 items in this class interval are below 16 kilograms, which means the other 10 are above 16 kilograms. The total number of items with mass less than 16 kilograms include the 4 which are in this class interval, these 20 and these 18. Or we can do the cumulative frequency, 38, plus the 4 that we've got in this interval, which gives us 42. So 42 items were below 16 kilograms. So let's have a look at this in more detail. The lower boundary here was 14.5, the upper boundary 19.5, and there are 14 items in this class interval. So here's a scale, our data scale, lower boundary, upper boundary. I've placed 14 items evenly distributed between 14.5 and 19.5 kilograms. Here is 16 kilograms, and we found 4.2 items, but we know that the number of items is discrete. You can't have 4.2 items. So 4 of them are below 16 kilograms and 10 are above 16 kilograms. I did not round the 4.2 down to 4, because if I modify the 4.2 value to, let's say, 4.9, even though this is not a part of our example, there are still 4 items that are below and 10 items which are above. So we're not rounding this value to the nearest whole number. We're looking at the number of discrete items to the left of this line and the number of discrete items to the right of this line. Part 2. What percentage of the data is below 16 kilograms? Well, 42 items were below 16 kilograms, and that's 42 out of a total of 60 items. So times 100, that's 70% of our data is below 16 kilograms. B, part 1. This time we're looking at the number of items which were above 16 kilograms. So the calculation starts as before. We substitute the same values in, because we've got the same numbers as before, and the frequency into the class again. When we rearrange, the interpolation formula gives us 4.2. So as before, 4 items were below 16 kilograms, 10 items were above 16 kilograms. We're going to use this value because we want above 16 kilograms, and there are 10 in this class interval above 16 kilograms plus these 8. And if we add them together, we've got 18. So 18 items were above 16 kilograms. And then what percentage of data is above 16? So 18 of the items out of 60 times 100, 30%. So 30% of our data is above 16 kilograms.